Hi everybody, it's currently 5:26. We will be starting our first ever topical live stream pretty soon, right? So please get your materials ready, right? Your stationery, the notes that I've given, right? And then we will continue later, right? At 5:30 sharp. All right, so it's 5:28 now. It will start in 2 more minutes. Okay, can get your materials, your stationery ready. Okay, and then we will go through today's very important, very high difficulty, but yet very fun topic on fraction word problems, right? Especially, I noticed that some of the students, right, both from Think Academy or not, right, they might need some more practice on fractions, right? So that's why we're starting off strong, right? Our first live stream will be on fraction word problems. Okay, the basic ones that you might see. Okay, 1 more minute. We shall wait for more of our students to join, and then we can start later. All right, in less than a minute. All right, so now I see that more and more people are coming in. Welcome, welcome. Right, we're starting our live stream soon. Please get your stuff ready, right? Both the materials and whatever you might need to take your notes. Okay, so yeah, it's currently almost there, right? We should wait for a few more seconds, a few more moments, right? So now it's already 17:30, right? 5:30 p.m., right? Which is our preset start time for our live streams. So let's proceed, right? Hi everybody, right? Welcome to our first ever, right, weekly topics live stream for high ability learners program math, right? Which is on fraction word problems, right? So actually, this is exactly 2 months, right, since the until the alleged exam date for HAL math, right? So without further ado, let's get started, right? Since this is going to be an information-packed, right, live stream, right? So before that, a brief introduction. I believe that most of the people watching should know me by now, right? But if not, hi, I'm teacher Yonglan, right? I am one of the P3 teachers in Think Academy Singapore, and me together with teacher Liz will be spearheading most of the events that is happening related to GEP math, right? So with that, not sure, right, if you have noted, right, that we have a community, hopefully that you have joined either in WhatsApp or WeChat every week, right, on Wednesdays, 5:30 to 6:30 p.m. Starting from this week onwards, right, there will be a live stream going through these weekly topics, right, that are important or forecasted to be important in the coming exam, right? And also there will be practice for you to submit online, right after this session, which I will post in both the WhatsApp and WeChat communities, right? And also on Fridays, we will be giving out a mock test paper every week, right? So a lot of submissions for week one are here already, right? I'm viewing through all of them and trying to look at some of the common pitfalls, right? Common mistakes that some of the students have. And then I will adjust our prep strategy based on that, right? So with that, today though, I want to remind you on one more thing, right? Actually, 2 days later, which is starting from 26th of June, there is this master book with top 30 core topics, right? For HAL Math that is available for collection. So for those who have registered, feel free to come down to any of our centers at Marine Parade, Orchard, Clementi, or Tai Seng to receive your copy, right? And yeah, before I continue, right, today's topic on fractional word problem. If you can hear me, please type a 1 in the chat box. If you can hear me, please type a 1 in the chat box. I want to see if the tech is working well, right? Can you hear me well? Can you hear me well? Okay, hopefully you could. Okay, with 1. Can. Very good job. Okay, now with that, I think everyone is okay. Let's proceed with our lesson today, right? So today we're going to talk about fraction word problems, everything about fractions, but I'm going to make sure to pack all of the most important info in 1 hour, right? Starting with a very basic question. Let's say that the figure below is made up of 7 rectangles of the same size. Right, what fraction of this figure is shaded? Quickly tell me, what fraction of this figure is shaded? That's right, it is. Good job, 5/7, right? Because we have 7 parts, of which 5 of them are shaded. Now, do you know, or rather, can you tell me, what is the name of each number, right, in the fraction on the top and at the bottom, right? For example, 7 refers to the number of equal parts in total. And can you tell me, this equal parts in total, we call this number the what? Start with a D, pretty long, right? We call this the denominator. And also for 5, right, that is the number of parts that are taken. And this number is called the numerator, right? So numerator over denominator. 5 out of 7 equal parts is what we selected. So this is how we write out a fraction and the definition of a fraction. Now, let's look at these 4 figures below, right? We have 4 of the same circles over here, right? Looking at the first circle, what is the fraction of the shaded part for this circle? This circle is 1/2, right? The next one, okay, how many out of how many equal parts? So some of you say, it's all 1/2, sure. But here I have 4 shaded parts, each of it is smaller, of course, and 2 of them are shaded. So I call it 2/4, right? 2/4. The next one is 3 out of 6 shaded parts, so 3/6, and then continue 4 out of 8 shaded parts, so 4/8. So you see, these fractions, right, the total number of parts are different, and also the shaded parts are different, right? So you look at the denominator, the wholes are different. The parts are also different, but are they referring to the same fraction? Or rather, are they referring to the same shaded part? Did my shaded part become fatter or skinnier in total just because I use a different numerator or denominator? Actually, I didn't, right? All these 4 fractions, they are referring to the same shaded part, right? They are referring to the same fraction, right? And these are what we call equivalent fractions. They have the same value, they represent the same portion, but the denominators are different, right? So what is the relationship between them, right? For example, from 1/2, how can I go to 3/6, right? Then you realize 2/6. I am basically cutting each part into 3 smaller parts. So I'm multiplying by 3. And the top part, also I'm multiplying by 3, right? So you realize that to get equivalent fractions, all you need to do is to multiply or divide the top and the bottom by the same number. Now, can I say 1/2 equals to, +1 + 1, 2/3? Is this correct? Can I add or subtract the top and the bottom by the same number? Cannot, cannot. Only multiplying and dividing, okay, the top and the bottom number by the same number. Now, among these fractions over here, Teacher Yonglam's favorite is actually 1/2 because this is what I call the simplest form, meaning I cannot divide the top and the bottom further, right? They are as small. The numerator and the denominators are as small as they could be. All right, so that is the fraction that we want, right? The simplest form. Okay, so with that, sometimes, or rather most of the time, when the question is asking for a fractional answer, it will require you to write it in the simplest form. So do take note of that, right? So now some more calculation, right? So who can quickly tell me 2 over 4 plus 1 over 4 equals how many over 4? 2 over 4 plus 1 over 4, how many over 4? Right? Can I say, oh, 3 over 8? Right? 2 plus 1 is 3, 4 plus 4 is 8. Cannot, when I am doing addition and subtraction, the denominators of the fraction will have to be the same, and you keep them as the same, right? So this is 3 over 4. And how about that next one? 2 over 3 minus 1 over 3. 2 over 3 minus 1 over 3, right? The denominator is the same. Keep it as a 3. And what's the numerator? It will be 2 minus 1 equals to 1. Good job, right? So when you are having addition and subtraction of fractions with the same denominator, you don't need to do anything to it, right? Just subtract the numerator or add the numerators up. All right, so hopefully everyone is very clear how to do this by now. But what if I have 1 over 4 plus 1 over 8? Right, can I just make it into 2 over 12? Right, the denominators are different this time. And to be very exact, you cannot do addition directly when the denominators are different. Right, so what exactly does 1 over 4 plus 1 over 8 mean? So let's imagine you have a bar and you cut it into 4 equal parts. Now 1 over 4 means 1 out of these 4 equal parts are taken. Right, now you already take 1 over 4. The next thing you want to take is 1 over 8. So you take the same bar and you take 1 out of 8 of it. And you combine. Right, so what fraction of the entire figure did I select? Okay, so with that, what fraction? So with that, if I have a different denominator, right, make sure you make the denominator the same first, right? Then you see, it's just 3 over 8. Right, now if I cut it into smaller parts, there are 8 equal parts. 1, 2, 3. 3 of them are shaded. Okay, so in that case, 1 over 4 plus 1 over 8 equals 3 over 8. How do I do that mathematically? I make the denominator the same first. Right, 1 over 4, I can make the denominator into 8. Right, so it becomes 2 over 8 plus 1 over 8. That will give me 3 over 8. Okay, and then how about 2 over 3 minus 1 over 4? 2 over 3 minus 1 over 4. Now, the denominator is still different. We need to make the denominator the same by multiplication, right? 3 times something and then 4 times something. Can you tell me what denominator will you choose? What denominator will you choose? If you see 3 and 4, you need to multiply both numbers until they reach a same denominator. Right? What denominator will you choose? Right, 3 and 4. Now, some of you will remember, you're finding the lowest common multiple. But either way, you can just list out the multiples of 3 and 4. Find out what is common, right? 3 times what and 4 times what? That's right. You make it 3 times 4, 4 times 3. Right, then 2 on top times 4, 1 on top times 3. The top and bottom, you should multiply by the same number. All right, top and bottom, multiply by the same number. So in that case, you will get 8 over 12 minus 3 over 12, which you will have the final answer 5 over 12. Now that the denominator is the same, okay, now that the denominator is the same, you can just add and subtract directly. All right, so with that, hey, that's how you do the basic of fraction addition and subtraction. Now, how do we use it in word problems, right? Let's take a look at this question, okay? Whenever you see a word problem, make sure you underline the keywords. Look at what the question wants, okay? So question 1, Benny baked a pizza for his family. Benny ate 1 over 6 of the pizza. So imagine you have an entire pizza. Benny ate 1 over 6 of it. And his brother ate 7 over 12 of the pizza. What fraction of the pizza did the 2 brothers eat all together? What fraction did they eat all together? Okay, now, what is the question actually asking for? Fraction all together. Fraction all together. Are we finding the sum or the difference? Are we finding the sum or the difference? Answer A or B, A or B, right? That's right, right? We are actually finding the sum. Very good, right? We are finding the sum. So we are adding the fractions up, right? So we have 1 over 6 plus 7 over 12. So we just need to find out what is the sum of these two fractions. Okay, how? 6 and 12. You realize that denominator is different, so we have to make them the same. Which denominator can I choose? Right, I have to multiply to get the same denominator. Which denominator should I choose? I should choose what denominator? Yes, multiply by 2, multiply by 2 to get 12, right? The LCM of 6 and 12 is 12. So I will just make the denominators both being 12. Now I know 6 times 2 is 12. So on top, 1 times 2, I should also get a 2. And then 7 over 12, I don't touch it. Then I just add the numerators up. I will get 9 over 12. Now, that means my answer must be 9 over 12. Yay, I'm done. I am done. Okay, my answer is 9 over 12. Am I correct? Am I correct? 9 over 12 lah. Yeah, that's the sum. Am I done? Or did teacher Yong Lam actually miss a keyword? What keyword did I miss? That's right? Simplest form. We want to express the answer in the simplest form. Meaning, can I actually make the numerator and the denominator smaller by dividing it with the same number? Which number can I divide it by? 9 divided by what? 12 divided by what? That's right, divide by 3, right? 9 divided by 3, 12 divided by 3. They are both in the times table of 3. So then you will get 3 over 4. And can you divide further? You cannot divide further. Right? So my answer is 3 over 4. That is how you get the correct answer. Okay, any questions so far? No question that. Okay, so addition, just need to check 3 things. Number 1, make the denominators the same. Number 2, add up the numerators. Number 3, simplify if you can. All right, now with that, let's take a look at the next question. Question number 2. Okay, now Emily knitted a long scarf. She used 3 over 5 of the yarn. Her sister used 1 over 4 of the yarn. How much more of the yarn did Emily use than her sister? How much more? Right, whenever you see the word more than, this time what are we actually finding? What are we actually finding? We are finding the sum or difference. Finding this time. More than. The moment you see more than, right? Be it fraction, be it whole numbers. How much more than, how much less than, you are finding the difference. So in other words, you are using the subtraction, right? We want to find out what's the difference between the two fractions. So we have 3 over 5 minus 1 over 4. And I see so many of you are commenting, make denominators the same. That's right? If the denominators are different, you cannot subtract directly. So 5 and 4, what denominator can you change it to? You want to multiply by something, right, onto each fraction to make the denominators the same. 5 can times what? 4 can times what? What denominator do you make it into? What denominator? 5 and 4. Think about what number is a common multiple of 5 and 4. That's right, you can do 5 times 4, which is 20, right? So you can do 20 here, 20 here, right? But how do we get to 20? 5 to 20, it's 8 times 4. Bottom times 4, on top also times 4. So 3 times 4 is 12. 4 times what is 20? Bottom times 5, on top times 5. So then 1 times 5 is 5. Okay, now 12 over 20 minus 5 over 20. What is the result? The result will be 7 over 20. That's right. Now, 7 over 20, we got it already, right? Can you simplify it? Can you divide both sides to make the denominator and the numerator smaller? Can you make the denominator and the numerator smaller? Well, unfortunately, I don't think you can, right? So you can just write your answer as 7 over 20. Sometimes you are lucky, the difference you get is already in the simplest form, then go ahead with it, right? Sometimes it's not, then you need to simplify it, right? By dividing the top and bottom. Okay, with that, right? Oh, some of you even give a decimal. Okay, but if the question says fraction, give it in fraction form, all right? Now, with that, that is just basic fraction, addition, and subtraction word problems, right? But sometimes we want to take fractions of a whole number, right? For example, let's say there are 12 apples and we want to divide it into 4 equal groups, right? So 4 equal groups, right? And divide it into 4 equal groups. In that case, can you tell me each group has how many apples? Each group has how many apples? Easy, right? 12 divided by 4 equals to 3, right? Each group has 3 apples. And then with that, you can get, right? Let's say I want to find 1/4 of 12. Now, 1/4, if I write it in fraction form, it will be 1/4 of 12. So 1/4, it's as if you're taking 1 out of 4 equal parts. We divided 12 into 4 equal parts, and we are taking 1 out of 4 equal parts, right? In that case, how many apples did we take out? Simply one group, right? One group is 3. That's it. Okay, now let me amp up the question, right? One group is 3. What if I have 3/4? I'm asking 3 out of 4. 3 out of 4 is how many? 3 out of 4 is just, right, 3 out of 4 equal groups. If each equal group is a 3, then I will just do 3 times 3 equals 9, right? So the answer is 9. Okay, so yeah, that's how you think about this. Now, however, what if I give you 1,200 apples? What, 3,693 apples, right? And you want to divide into a lot of groups. Do you really want to draw all the apples out? No, you don't, right? So sometimes you will use a bar model to represent it instead, right? So if I want to split it into 4 equal groups, I will just draw 4 equal units, and the total is 12. Now, if I ask you 1 out of 4 of 12, you are basically finding what is the value of 1 unit, right? I already tell you, I'm splitting the entire group into 4 equal parts. So each part, I can treat it as 1 unit, 1 unit, 1 unit, 1 unit, right? So total 4 units, 4 units equal to 12. Then you can find out what is the value of 1 unit, right? 1 unit is just, since the 4 units are equal, you can do the, right? 12 divided by 4 equals to 3, right? So since 1 unit is equal to 3, that is means 1 part is a 3. 3 out of 4 means I need to select 3 equal parts. 3 equal parts, that is 3 units, which is just 9. Okay, so in conclusion, if you are seeing a fraction of a whole number, you will draw the total number of units first, based on the denominator. 1 out of 4 means there are 4 units in total. Then you know the total, you label the total. From there, you'll find 1 unit before you multiply by the numerator. Okay, now that being said, let's take a look at question 3 now, right? How to use it in a word problem scenario. Now, teacher Emma had 56 guppies. Guppy is a type of fish that people use to rear, right? Looks something like this, right? So we have 56 guppy fish, and she gave 2/7 of them to her friend, and she kept the rest for herself. How many guppies did she give away? How many guppies did she keep? Now, this question has one fraction, right? 2/7. So it's relatively simple. Now, in that case, we try to solve it using a bar model, right? Instead of drawing 56 guppy fish. Now, let's draw a bar model first, right? Everyone can draw together, right? Now, while we draw the bar model, right? Please ask yourself this question. How many units should you split this model into? How many units should you split this model into? 2 out of 7. Should you split it into 2 units or 7 units, right? Think about 56. 56 is the total, right? So which part of the fraction is about the total? Is it 7 the total or is 2 the total? Right? We already said before, the numerator is about the parts that is taken. Denominator is the part that is the total, right? So let's just say in total, there are 7 units altogether, right? And now you cut the units already, right? First, cut the units, 7 units, right, in total. Then we try to label any information we know according to the question. For example, the question told us 56. 56 is the total. So of course you label it for the entire bar, right? 56 is the total, which means the entire 7 units add up to be 56. Okay, 7 units add up to be 56. So which can you find? Right, in fraction word problems, it's very important if you can find the 1 unit, right? So 7 units is equal to 56. So from there, you can find 1 unit is equal to 56 divided by 7, which is 8. Okay, so now there are 8 fish in a unit. Now, how many units did she give away though? Question 1, how many copies did she give away? So now we need to think, how many units did she give away? 2 out of 7 was given away. So you will label 2 units as the giveaway part, right? So these are all equal unit, right? 1 unit, 1 unit, 1 unit, 1 unit, 1 unit, 1 unit, 1 unit. She gave 2 units away. So you can just find 2 units is equal to 2 times 8 equals 16. Okay, so she gave away 16 guppy fish. That's the part that she gave away. Now, can you quickly tell me, how many did she keep? How many did she keep? There are 2 ways to do this, right? How many did she keep? Good, good. Number 1, you can just look at how many units did she keep, right? So maybe teacher Yonglam can label like this. This is the entire part that she keep, which is 5 units. So 5 units, you can write it as 5 times 8 equals to 40, right? So you can have 40, for example. Or you can simply take the total minus the part she gave away, right? So, or you can take the total number minus the part that she gave away, right? For 56 minus 16 is 40. And you're right. 2 ways to do it. Good job, everybody. Right. This question is relatively simple because there's only one fraction, right? So just make sure the denominator is used for the total number of units. And you label how many units are there in each part according to what is given in the numerator. Right. Now, when there's one fraction, it's pretty simple, right? Don't get it wrong. Please don't get it wrong. Okay. However, in the next question, something sus, right? Let's take a look. Damien sold fruits at the market. 1/2 of the fruits sold were pineapples. 3/8 of them were mangoes, and the remaining fruits were papayas. There were 24 papayas. How many fruits did he sell altogether? Right. 3/8 of them. Wait a second. Let's read the question again. There's something sus. First, you know that 1/2 of the fruit, that means the total, were pineapples. Then 3/8 of them. This them also refers to the fruits, right? This time there are 2 fractions given to you, right? Among the total, 1 fraction of it were pineapple, another fraction were mangoes, etc. Right? And the rest were papayas. Okay, so this 2 fractions. How should you draw the model? How should you draw the model? Right. So teacher Thomas advice to you, when you see 2 fractions, don't panic. Start by asking a pretty easy question, right? Are both fractions denominators referring to the same total? Meaning 1/2 of the fruits, 3/8 of the fruits. Am I taking both fractions from the same total? They are taken from the same total. Are these 2 fractions taken from the same group of fruits? Actually, yes, right? Because I'm taking 1/2 of the fruits and also 3/8 of the fruits. So I'm actually talking about the same total. I'm taking both fractions from the same total. In this case, how can I show 1/2 and 3/8 at the same time? Should I draw 2 units or 8 units? There are 2 fractions. Should we draw 2 units or 8 units? Or some people say, we are learning English. That's right. In past GEP or even like HAL nowadays, we can foresee a lot of word problems. That's why it's important to read the question and understand the exact scenario they are talking about. Right. So we want to express 2 halves and also 3/8 in the same model. So we will draw a same bar model with the same equal units and label both fractions together. Meaning we need to choose the denominator wisely. Right? Our pineapples, there are 1/2 of them. Our mangoes, there are 3/8 of them. What denominator should I choose? Or in other words, which way should I use to choose the denominator? Should I just blindly multiply? Should I just add? Or should I find a lowest common multiple? Right? That's right. We try to find a lowest common multiple. Right? What does that mean? Lowest common multiple means which number, what is the smallest number that appears in 2 times table and 8 times table? What is the smallest number that appears in 2 times table and 8 times table? That's right, it's just 8. Right, so can 2 times something become 8? 2 times what is 8? 2 times 4. Good. 2 times 4 is 8. Right, so the denominator, I change it to 8. On top, the denominator, I change it to 4. Right, bottom times what? On top also times what? Equivalent fraction, top and bottom, you multiply by the same number. Right, so for 3 over 8, I actually don't need to touch it because the denominator is 8. Now that I have the same denominator, that means I need to label the model. I can draw the model with how many units in total. Since we found that the denominator that is common, we can use it split. That means I will try to split the model into 8 smaller units, right? So to split it, you don't need to draw from the left to the right. You can just cut into half first, right? Cut further. Right. Anyway, we get 8 equal units. Anyway, we get 8 equal units. Draw the bar model, and then now you label any fractional part, any information that you know. Right, so first of all, 1 over 2 of the fruit sold were pineapples. We changed it to 4 over 8. That means how many units are pineapples? 4 over 8 means 4 units are pineapples. And then 3 over 8 of mangoes, 3 over 8 of them are mangoes. So mangoes is 3 out of 8 units. So I label 3 units as mangoes. And finally, what about the last unit? What is the last unit? I have pineapples, I have mangoes. The remaining were papayas, right? So papaya is the remaining 1 unit, which you know what's the value of, right? If after you label the fractional parts, look at the question. What quantity do you know? What number do you know? You know there are 24 papaya. So that means this papaya amount is 24. Just like 1 unit is equal to 24. Now that you found 1 unit, we look back. The question is asking, how many fruits did he sell altogether? Now that you found 1 unit, don't just give 1 unit as the answer. Look back at the question. The question is asking, how many fruits did he sell altogether? So altogether, that means the entire total. Whoop. Let me draw again. The entire total, there are how many units? How many units? How many fruits? There are 8 units. So 8 units is equal to 24 times 8 or 8 times 24, right? Any quick calculators out there? Who can calculate what is 24 times 8? 24 times 8 is equal to 24 times 8 is equal to 192. Correct. So my answer is 192. Good. Okay. Right, so the SOP is there, the standard steps are there. You see 2 fractions, ask yourself, are they taken from the same total? If they are, you draw them in a single bar model together. Draw them in a single bar model together. But then you need to figure out, right, how many units you need to draw. That's why you look at a denominator. Pick a common denominator by multiplication. All right. Now, if this is your first ever time doing this, it's okay. I have more practices as well. Right. The next question is sort of similar. Right. Let's get ready for the next question. Okay. Good job, everybody. 192 is the answer. Right. Now let's take a look at question 5 and read the question carefully. Underline the keywords as you go. Right. In a sushi platter, 1 over 3 of the sushi. 1 over 3 of the sushi are tuna sushi. 1 over 4 of the sushi are unagi sushi, which means eel, and the remaining, the rest, are salmon sushi. Now, there are 76 more salmon sushi than unagi sushi. Take note of the number, 76 more, right? So we are comparing. All right. And now, how many pieces of sushi are there altogether? How many pieces of sushi are there altogether? How many fractions do you see this time? How many fractions do you see this time? You see 2 fractions. So when you see 2 fractions, don't panic. Don't draw the bar model cut right away. Ask yourself first, are the 2 fractions taken from the same total? When I say 1 over 3, when I say 1 over 4, are these 2 fractions taken from the same total? 1 over 3 of the sushi 1/4 of the sushi, yet they are taken from the same total. Right, so since they are taken from the same total, what do? You draw them together, right? Draw them in a single bar model, which means it's time to think, what denominator would you choose? Tuna, 1/3. Unagi, 1/4. What denominator will you choose? Now, obviously, you cannot draw 3 units and 4 units together. What would you choose? Times what? 3 and 4. What's the common denominator that you will choose? Right? You multiply by a certain number for each of them. Right? 3 and 4. What number will you multiply each of them with? Or rather, what denominator will you make? What denominator will you make? 3 and 4. Will I just do 3 plus 1? No, we multiply. Right? What's the common multiple of 3 and 4? 3 and 4. 3 and 4. What's the common multiple? That's right, it's 12. Right, so 3 and 4, LCM is 12. If you are not sure, you just list up the multiples of 4, right? 4, and then check, is it a multiple of 3? Can 3 times something be 4? Cannot. Right, can 3 times something be 8? Cannot. Can 3 times something be 12? Can 3 times 4 is 12? Just nice, 4 times 3 is 12. So we want to make it into denominator 12. Right, now, can I just say 1? Cannot, right? Equivalent fraction means whatever happens at the bottom will also happen at the top, right? 3 times 4 at the bottom, 1 times 4 at the top. So it's 4. 4 times 3 at the bottom, 1 times 3 at the top. So 3/12. All right. So with that, you know the denominator you want to set is 12. So we will draw 12 units in the bar model. Now, some of you might think, Teacher Yona, do I have to draw from the left to the right? Don't need. Right? You can split it into smaller pieces and then split further. For example, maybe I cut into half first. Then I cut into 4 equal units. Right? Then each equal unit, since there's 4 units now, I want to make a 12. I cut each unit into 3 smaller units. And there I have it, right? 12 exactly equal units. And I can label the fractions now, right? 4/12 is tuna. So I'll label 4/12 here. 3/12 is unagi, so 3 of the units are unagi or eel, right? They mean the same thing. Okay, and the remaining are salmon sushi, right? So the remaining is salmon. Now, we label everything in the fraction model. It's time to check what is the value of 1 unit. What number or what value do you know here? What number do you know here? The value you know is 76. Right. Okay, stop spamming in the chat. The answer 12 is very outdated. Right. I'm beyond 12 already. Okay. So 76 is the number that you know. Does that mean, oh, salmon is 76? Is that how it works? No. Read the question again. What's the meaning of 76? There are 76 more. Oh, more than. So the 76 is the difference of something. It's the difference between salmon and unagi. So we need to find the difference of salmon and unagi in terms of units as well. Right, salmon, I have 5 units, right? 1, 2, 3, 4, 5, 8, 4, 5. Unagi, I have 1, 2, 3 units. So what's the difference between them? 5 units minus 3 units equals 2 units, which is 76. And from there, you can find out 1 unit is equal to what, right? 1 unit is 76 divided by 2 equals 38. Then read back at the question. The question is asking how many pieces of sushi are there all together. So all together means the entire bar model. All the units add up together. Right? All the units add up together. So then we know 12 units is equal to 12 times 38. Since we're finding total, you just find out all the units. How many units are there? Multiply by the value of 1 unit. Now this is a bit rough, right? You just need to do your vertical addition. Sorry, vertical multiplication carefully. Right, 12 times 8, 96. 12 times 3, 36. But remember, it's 3/10. So put a 0 first, and 36. Then add them up, it's 456. Right, so the answer is 456. That's it. That's how you get it. Okay? Oh, okay, so far. Any questions? Is anyone blah blah? Okay, the same thing applies. Find a common denominator before you draw the entire bar model for everything. Right? Okay, if you are still confused, it's okay. Teacher Yongla will have one more similar question for you. Are you ready? Ready? Okay, let's go. Now, the next question says, read the question together. In a school, 1/3 of the pupils walk to school, 2/9 take the taxi, and the rest of them take the bus. Now, 1/3 of the pupils walk to school. So the 1/3 comes from the pupils, right? Entire pupils of the school. Right. So this is the first fraction. 2/9 take the taxi. 2/9 is another fraction. But do you know it's 2/9 of what? In other words, is my 2/9 coming from the same total as the 1/3? Is 2/9 coming from the same total as 1/3? Yes or no? 2/9 of what? It's still the same total, right? Of the pupils. It's 2/9 of the pupils. Very good. So my 1/3 and my 2/9 are coming from the same total. Okay? Which means you need to draw the bar model together. Right? But before you consider that, don't forget, read the entire question first. Okay? They come from the same total, right? 1/3 of the pupils, 2/9. If I didn't mention that, if I didn't mention anything suspicious, they are all still referring from the same total. 1/3 of the pupils, 2/9 of the pupils. So these two fractions are still referring to the same total. We need to draw a bar model using some equal units. Okay? So also the question says that 800 pupils go to school by bus. How many pupils are there in the school? Meaning the entire total. All right? Now, in that case, we have two fractions now. Walking to school is 1/3. Take the taxi, 2/9. Can I draw 3 units and then 9 units together? Cannot, right? When I draw a bar model, every unit should be the same. When I draw a bar model, every unit should be the same. Meaning, right, I need to change them into the same denominator. So what denominator will you choose? 3 and 9. Can 3 times something to become 9? Or should I multiply both of them together? What denominator should I choose? What denominator should I choose below? Any ideas? Yes, it's the same total. But what denominator should I choose? 3 and 9. I need to choose a common multiple, right? I don't just add them. I don't just anyhow multiply, right? You might think, teacher, I can just do 3 times 9, 9 times 3 law. I get 27 law. And if you want to draw 27 units, I go ahead, right? But is there a smaller number of units that I can use? Is there a smaller number of units? There is, right? In fact, what is the LCM of 3 and 9? What's the least common multiple of 3 and 9? It is 3 times 3, which is 9. 9 times 1 also gives you 9. So 9 is, fortunately, a common multiple of 3 and 9. So I will just multiply top and bottom of the first fraction by 3. I will get 1 times 3 equals to 3. Bottom, I don't touch it, right? 2/9. Okay? Now with that, you know you need to draw how many units for your bar model? How many units for your bar model? 9 units, right? So let's draw 9 units. I can first split into 3 bigger blocks, and then each of them split into 3 smaller blocks, right? So then there are 9 units in total. Then we label the number of units, right? For each of the walking, taking taxi, each of the modes of transportation, right? For walking, 3 out of 9 units. So 3 units is for walking. Taxi, 2 out of 9 units. Okay. And finally, the rest is taking the bus. The rest of them take the bus. So the rest I will label the bus. How come there's a bracket beside that, right? Is there something else I can label? Is there something else I can label, right? After we label all the fractional part, right? How many unit, how many unit, how many unit? it's time to label the number, the value that you know according to the question. Now the question says 800 students go to school by bus. So bus, I have 800 students. Okay, stop spamming. 9 is an outdated answer. 9 is an outdated answer. No more 9. Okay? All right. Anyway, we know that 800 students take the bus. Can you relate it to the number of units? That's right. 1 unit, 2 unit, 3 unit, 4 unit. 4 units is equal to 800, which means now you can find what's the value of 1 unit, right? 1 unit is simply 800 divided by 4 equals 200. 1 unit is equal to 200. We are finding how many pupils are there in the school. So the entire school. Altogether, how many people are there? Altogether, how many people are there? This number. So we need to find the total number of units. Right? How many units are there? Right? So 1, 2, 3, 4, 5, 6, 7, 8, 9. 9 units in total. That will be just 200 times 9, or 9 times 200, which is 1,800 pupils. Right? That will be your final answer. Yes, 1 unit is 200. So then you will just multiply by 9 to get the final answer. All right. Oh, okay, so far. Oh, okay. Yes, 4 out of 9 is 800. So from there, you find out 1 unit before you multiply by the number of units you desire. Okay. All right. With that, that is the first type of question, right? When you see two fractions, they are both taken from the same total. Just find the same denominator and then draw together. Now, what about the next question? Let's see. The next question says, there are 100 ornaments on a Christmas tree. Ornament means the decoration on the Christmas tree, right? 100 ornaments. 1 over 5 of the ornaments are gold. 1 over 5 of the ornaments, that means the total. 1 over 5, the entire total, are gold. But here's the next part. Read the question carefully. 1 over 2 of the remaining ornaments are silver. How many ornaments are neither gold nor silver? This time, I still have two fractions. Right, 1 over 5 and 1 over 2. Did I take the 1 over 5 and the 1 over 2 from the same total? Did I take 1 over 5 and 1 over 2 from the same total? Did I take 1 over 5 of the total and then 1 over 2 of the total? Did I? Yes or no? Yes or no? Yes or no? Type in the chat, yes or no? Right. Hey, you might notice there's a pesky little word here, right? Remaining. Right. So 1 over 5, of course, I take from the total. Right. Imagine, okay, I have this many ornaments. I take 1 over 5. Okay, these are gold. Did the 1 over 2 come from the total as well? No, it comes from remaining. Remaining means now, before I take the 1 over 2, I focus on the part that hasn't been taken away. And then I take 1 over 2 out of it. It's silver. Okay, so these two fractions are not referring to the same total. Then how? If they are not referring to the same total, should I still cut into smaller parts, find the equal denominator? Don't need. If the two fractions are referring to the different total, if I take from the total and then take from the remaining, then we will draw out the fraction step by step. Okay, draw out the fractions step by step. We take the different stuff step by step by following the order of the story, right? So, which fraction should I start from? Which fraction should I start from then? Which fraction should I start from? That's right. The fraction that is taken from total, which is 1 over 5. 1 over 5 of the total are gold, right? In that case, we will first draw a bar model and first focus on the fraction that is talking about the entire total. 1 over 5 of the entire total. So, don't have to think about the other fraction first. We focus step by step. We draw 5 units first. We try to take out the 1 over 5 first. Take out the 1 over 5. That means I split it into 5 units, right? 1 unit, 1 unit, 1 unit, 1 unit, 1 unit. Now, 1 over 5 of the ornaments are gold. That means I will take 1 unit away from them. And it's gold. Okay, now before you proceed, there is also another number that you know. And what do you know? You know that 100 ornaments there are, right, on a Christmas tree. There are 100 ornaments in total. So you can also label the total as 100. The answer is not 30. The answer is not 30, right? Sure. Right, I will say why the answer is not 30, okay? Right, some of you might think, oh, it's the same as the previous question. No, because look at the next fraction. The next fraction says, I take 1/2 of the remaining and make it silver. Does that mean I am still taking 1/2 of the entire total? Am I still taking 1/2 of the entire total? No. Where is the remaining? Remaining means whatever is left after I take away what was previously labeled. I take away the 1 unit that is gold already. So the remaining refers to the 4 units that are left. Among the 4 units, 1/2 are silver, right? So whenever you see the word remaining, you draw the fraction step by step. Take the first part first, take away the first fraction first, then focus on what is left. You take away the first fraction, take away the first fraction, then focus on what is left. This is the remaining part. Among this remaining part is where you take the 1/2. Okay? That's why teacher Yong Lam actually has a good idea for you. Whenever you see the word remaining, draw the fraction step by step. And to remind yourself to not pick from the same total, I would take out a samurai knife, right? And then do a very clean cut, right? Not that clean. Do a very clean cut over here, right? To separate what was taken and what was remaining. Now, among 4 units remaining, 1/2 are silver. So how many units are silver? How many units are silver? That's right. Among 4 units, half of it are silver. So 2 units are silver. 3 units are neither gold nor silver. Right. Now, in that case, you just need to think, okay, I want to find the number of the neither. That's 2 units. Can we find 1 unit first? Yeah, we can, right? The total is 100. How many units is the 100 anyway? 1, 2, 3, 4, 5. The entire total is 5 units, which is 100. From there, you can find out 1 unit is equal to 100 divided by 5, which is 20. And to find out the neither part, that is just 1, 2. 2 units is equal to 2 times 20 equals 40. Right, so my answer is 40 ornaments. Okay, this is still considered easy. Wait till you see the next question. The next question is going to have even more steps. So pay closer attention to what will happen later. All right. Here, just need to take note. When I see 2 fractions, don't straight away panic and find the LCM. Cut. When they are referring to different wholes. Usually, when you see the word second fraction of the remaining, then you know these 2 fractions are taken from the different totals. And all you need to do is to consider the fractions step by step, one by one. Take away one part, then focus on the remaining. All right, everyone cool to go? Right, I sense that it's getting a bit more complicated. It's okay, I still have more coming up. Right, let's look at the next question. Right, next question says, Belinda spent 1/3 of her money, 1/3 of her money to purchase a pair of shoes. Then she spent 2/5 of the remaining money to buy an enormous bucket plushie, right? Eh? What's the pesky little keyword that you see here? Is this 1/3? And 2/5 coming from the same total? Think about it as we read the question, right? If she had $60 left at the end after all purchases, how much money did she have at first? Okay? Now, my question, number 1, are these 2 fractions both coming from the same total? Did I take out 1/3 of the money and then 2/5 of the money? Or do you see any word that tells you it's not the case? What's the word that I circled very hardly just now? What's the word that I circled very hard just now? That's right, remaining. Right, if I say remaining, that means first I have a lot of money. I take away one part of it to buy shoes first. Then I focus on whatever is left. I focus on whatever is left. From there, I take out the next part. for the plushie. All right. Yes, the word remaining. Good. Okay. Now, with that, let's draw the model together. Right. If it's different holes, we draw out the fractions step by step. Okay. So let's draw a bar model. Focus on the first fraction, 1/3. That means I will cut it into 3 equal units first. Okay. So this is 1 unit, 1 unit, 1 unit. Okay. And that 1/3 of it is used to buy shoes, right? So we label 1 unit for shoes. Okay. And then we focus on the remaining now, right? The next fraction is taken from the remaining. So we cut out the remaining first. Okay. Now I have 2 units. I want to split it into 5 equal parts. Can I split it into 5 equal parts? Can I just cut like this? Can I split is this 5 equal parts? Cannot. Right. So if you realize you cannot cut the existing units into equal parts as required, you will need to redraw and redistribute the remaining. Here's a key point. You need to redistribute the remaining. Okay, redistribute the remaining. So let's draw the whole thing again, right? Let's focus on this remaining part. This is the part that is remaining. And we want to spend 2/5 of the remaining to buy a plushie, right? So then I will split it into 5 equal parts. So split it into 5 equal parts. You see, I'm combining the remaining parts and redistributing them, resplitting them, right? So this time, each part is a smaller unit. I'll give it another name, right? Maybe this is 1 part, P for part, 1 part, 1 part, 1 part, 1 part. And 2/5 of the remaining means I use 2 parts to buy the plushie. Use 2 parts to buy the plushie, and the remaining 3 parts is just whatever is left, which is how many dollars? The question did say that. It's how many dollars? It is $60. Right. Oh, the answer is not 120, the answer is not 180. Right. But you see what I'm doing now? I'm spending 1/3 of the money. Then the remaining, I redistribute it into 5 equal parts. 2 parts are used for the plushie. 3 parts are left, which is $60. Now, can you find 1 unit yet? 1 unit? Perhaps it's a bit hard. But you know, 60 is just 3 equal parts. So then let's focus on the remaining first. Focusing on the remaining, 3 parts is equal to 60, right? 1, 2, 3. 3 parts is equal to 60. So then you can find out 1 part is equal to 60 divided by 3 equals 20. And from that, you can find the remaining money. We go step by step back. Right? 60 is 3 parts. Can we find the entire remaining parts first? Yes, we can. The remaining 5 parts is equal to 20 times 5 equals 100. Right? That means the remaining at first is 100 before she spent on the plushie. This entire part is 100. But does that mean 100 is our answer? But does that mean 100 is our answer? 100 is not the answer. I'm asking how much money she have at first. That means before she even spent any of her money, how much money did she have originally? So does it only include these 2 units? No, there's still 1 more unit that she used for her shoes. So since you know this remaining part is 100, can you calculate the total amount of money at first? Yes, you can, right? So at first, you know that 1 unit, 2 unit, 2 units is equal to 100. So then 1 unit is equal to 100 divided by 2, which is 50. And with that, the total amount of money at first is 1, 2, 3, 3 units. 3 units is equal to 50 times 3 equals 150. Right? So with that, you know that there are $150. So it's not 450, 1 unit is 50, so 3 units is 150. Okay? All right. So yeah, this is slightly difficult because the remaining part cannot be directly split into smaller equal units. You need to redraw, redistribute, right? Just like what you might see in the next question. Okay, ready for the next question? Okay, let's go to the next question now. Now, the next question is saying that Matt had a piece of wire that was 280 cm long, right? So this 280 cm is the total length at first. At first, it is 280 cm long, right? Then he used 2/7 of it to make a bookmark, and 3/4 of the remaining 3/4 of the remaining wire to make a basket. What is the length of the remaining unused wire? At the end, there is still some part that is not being used. How much of it? Right. So same thing. Since you see the word remaining, do you think the two fractions are taken from the same total? 2/7 of the total. 3/4 of the total. Is it? No, they are not taken from the same total. So we draw out the fractions step by step. Follow the story. First, 2/7 of the total. So you first draw out the model, split it into how many units? 2/7 of 8. So this 8 is referring to the initial total. So we focus on labeling out 2/7 first. Label out 2/7 first, right? So that we label 7 parts. These 7 parts, you also know the total length, right? The total length is 280 cm, right? So first, label 7 units, right? And the total is 280. From that, you can find out, oh, I use 2/7 of it on a bookmark. I use 2/7 of it on a bookmark. So you label 2 units for the bookmark. And now 3/4 of the remaining. Haha. So which part is the remaining? Actually, it is these 5 units. These 5 units is the remaining after bookmark. So you can label slightly remaining first. Right. But then now what fraction of it is taken away? Right. What fraction of it is taken away? 3/4 of the remaining. Hello, you have 5 units here. You have 5 units here. I have 5 units here. How are you taking 3/4 of 5 units? Can you cut 5 units into 4 equal parts? Not that easy, right? So that's why we need to redistribute the remaining part again. Meaning, we focus on the remaining part, draw a new model. Draw out a new model, and then we try to label 3/4. 3/4 means I redistribute it into 4 equal parts. Now, among these 4 equal parts, 3 of it I use for the basket, right? Because 3/4 I use on the basket. The last one is the unused part, which is what we are trying to find. Right. Now, in the previous question, we are going from small to big. Now we are going from big to small. Given the total, we want to find the unused part. So when should I start? Right, we will start from the 280. And we figure out, after I take out the bookmark wire, how much wire is left. Right, so initially, it is 280 cm. Then we find out after the bookmark, how many cm is left. So initially 280 is how many units, right? In total, there are 1, 2, 3, 4, 5, 6, 7 units. So initially 7 units equal 280. From there, you find out 1 unit is equal to 280 divided by 7, which is 40. But we want to find out after we use up the bookmark part, how much is left. So how much is left? We count the units carefully. 1, 2, 3, 4, 5. 5 units equals 5 times 40 equals 200. Okay, yes. Some of you got the answer already. Right, so now the remaining part is 200, right? So this remaining part is 200 cm. But I continue to use it on the basket. Right, so now we redistribute the 200 cm into 1 part, 2 part, 3 part, 4 part. Notice I didn't use unit here because this unit and this unit are 2 different quantities. So I cannot say this is also a unit, right? So we focus on how much is left after I use some of them on the basket. I redistributed the remaining part, so 4 part is equal to 200. So with that, what is the value of 1 part? 4 part is 200. What is the value of 1 part? Equation? 200 divided by 4, right? So it's 200 divided by 4, which is 50 cm. And just like the unused part is just 1 unit, right? So it is 50 cm. And there we have it, the answer. Oh, 50 cm. All right, yes, the answer is 50 cm. Some of you got it already. Good job. Okay, right. So that's the other type of the problem. When you see two fractions, take from the total, take from the remaining, label out the fractions step by step. Sometimes you need to redistribute the remaining part to draw out the models for the remaining part again. Okay? Yes. Now with that, moving on, the final question of the day, right? This is a bit suspicious, right? Let's read the question. Okay, it's a bit different. There are some boys and girls performing on the stage, right? Then 1/2 of the boys is equal to 2/3 of the girls. Okay, if there are 84 students on the stage altogether, how many boys are there? Please ignore this word, right? How many boys are there? Yeah, how many boys are there? Now, how do we draw the model? Right, this time, are we taking two fractions from the same total? No, because we are actually comparing the number of boys and the number of girls. I'm saying there are some boys, there are some girls. I'm talking about some relationship between the two types. So when there are two types of stuff, right, we will draw a comparison model to draw the two types. However, it's an important question. I see the word equal. I see the word equal. Does that mean I have the same total boys and total girls? Right, please answer this question. Fill in the blank. The parts of the boys and girls or the totals of the boys and girls have the same number. Did I say total boy equal total girl or part of the boy equal part of the girl? Total boy or total equals total girl or part of the boy equals part of the girl? It's actually a fraction of the boys. That means not all boys. Part of the boys equals to a fraction of the girls. Part of the boys equals part of the girls. Right. So there are some boys that are equal to the girls. Right. Some part of the boy is equal to some part of the girl. There are two parts that are equal. So let's label the two equal parts on the bar models. Okay? So part of the boys is equal to part of the girls. So you draw out the equal parts first, right? Draw out the equal parts. From there, you try to expand to find out how the total boys and the total girls look like. Now over here, I say 1/2 of the boys is equal to 2/3 of the girls, meaning this is 1/2 of the boy. So this is just 1 unit. How many more units do I need to draw for the total boys? Is this the total boys? No, it's 1/2. This is just 1/2 of the boys. So I need to draw an extra unit for the boys, right? This is the total boys. 1/2 of the boys is used to compare to the girls. So actually I have this much boys. How about the girls? 2/3 of the girls. So this unit here, or rather this part here, is 2/3 of the girls. How many units of the girls are in the part? Should I split this into 3 or 2? 1/2, 1 unit out of 2 units. 2/3, then actually the part over here should be 2 out of 3 total units. So I need to split it into 2 equal units first. I need to split it into 2 equal units first, and then it's 2 out of 3 units in total. I need to add an extra unit at the back. And with that, we can label the total is 84. Right? Okay? Okay, so now I'm done, right? I have 84. Does that mean there are 1 unit, 2 unit, 3 unit, 4 unit, 5 unit? Yeah, 5 units equals to 84. Am I correct? Can I say 5 units is equal to 84? Is this the correct way to express the unit? What do you think? Is it 5 units equals 84? No, right? When we compare units, right? When we want to say how many units are there in total, make sure the total, like all the units here, are of the same size. This and this are two different sizes. Of course, I cannot say this is 1 unit and this is also 1 unit. Right? So in other words, I need to split them into equal units. So answer me, this big part, I can split it into how many units? This big part, I can split it into two smaller units. Likewise, this big part, they are the same, and we'll split it into two smaller units. So with that, how many units are there altogether? 1, 2, 3, 4, 5, 6, 7. 7 units equals 84. And then you can get 1 unit is equal to 84 divided by 7 equals 12. Every unit is a 12. Finally, you just need to find out what the question is asking, right? The question is asking how many boys are there. So focus on the boys. There are 1, 2, 3, 4. 4 units equals 4 times 12 equals 48. So there are 48 boys. Okay, when we are comparing two types, draw a comparison bar model. Part equal part, you draw out the equal part first, and then you try to split accordingly, right? And then expand from the part to the total using equal units. Finally, when you compare across both categories, make sure every unit is the same size. All right. Now, with that, that is the final question of the day, right? Congratulations, everyone, for going through the entire session for today. Okay. So with that, here are some key points to remember for fraction word problems, especially when you see two fractions. When you see two fractions in a fraction word problem, if they are referring to the same total, make the denominator to be the same. If they are referring to different total, right, you need to split and consider the fractions one by one. Don't need to split into a common denominator first, right? Don't need to split into common denominator. Do it one by one. And finally, if I say a fraction of A equals a fraction of B, draw the comparison model. Change everything to the same small unit. Okay, with that, that is all for today, right? If you have any questions, feel free to raise up in the chat or talk about it in the group chat. Okay, and yeah, do note that there is actually some practice right after today's lesson, right? If you look at your handout, question 11 to 20 will be the post-class practice, which you can submit online, right? I'll share the link in the group chat later, right? And this Friday, there will be a second mock test being released, right? The first mock test, I will also share the solutions in due time. Okay, so with that, that is all for today's session. Please remember to do the practice, right? Hopefully, I can see a lot of 100 today. Okay, with that, I will see you next week. Okay, what topic will I be going through? Secret. All right, so with that, that will be the end of today's session. Any questions? Feel free to raise them in the chat or talk to me later in the WhatsApp or WeChat community. Okay, question 11 to 20, yeah, those are the online practice. Those are the practice that you can do and then submit online. Okay, with that, that's the end of today. Goodbye, everybody. All right, bye-bye. Any questions so far? Any questions? Feel free to read in the chat. Okay. All right. I will see you guys next week. Goodbye.